Step outside on a clear, dark night and look up. The universe reveals its wonders. The air feels cooler, the world quieter, and above you, a vast expanse stretches farther than the eye can see. In that moment, you're not just standing on Earth, you're standing at the edge of infinity, peering into the depths of space and time. The sky is a black canvas, scattered with countless points of light. Each one is a beacon, a story, a mystery waiting to be unraveled. Some shine bright and steady, while others twinkle and fade, hinting at the secrets they hold. For millennia, humans have connected these dots, navigated by them, and wondered, what are those lights, and how many are there? Ancient civilizations drew patterns in the sky, creating myths and legends, using the stars to guide their journeys across oceans and deserts. That awe is the spark of science. It's the feeling that drives us to ask questions, to seek answers, and to explore the unknown. Every discovery begins with a sense of wonder. When you gaze at the stars, you're seeing distant suns, some close, some so far their light began its journey before humans existed. The light you see tonight may have traveled for thousands, even millions of years, crossing unimaginable distances to reach your eyes. On the darkest night, you might see a few thousand stars, but that's just our local neighborhood in the Milky Way. Our galaxy alone is home to hundreds of billions of stars, most invisible to the naked eye, hidden by distance and dust. It's like counting houses on your street and guessing the world's population. What we see is only a tiny fraction of what's truly out there, a mere hint of the universe's true scale. To truly grasp the number of stars, we must look beyond our galaxy, into the vastness of space. Telescopes like Hubble have revealed billions of other galaxies, each with their own stars, planets, and mysteries. We can't count every star, but with telescopes and clever math, we can estimate. Astronomers use powerful instruments and computer models to peer deeper, measuring the faintest glimmers of light and mapping the cosmos. We start with what we know, our galaxy, and use it as a model for the cosmos. By studying the Milky Way, we unlock clues about the structure and scale of the universe itself. This journey is filled with challenges, but it reveals a universe more grand than we ever imagined. Each discovery expands our sense of what's possible, reminding us that we are part of something vast and extraordinary. So, let's begin our cosmic census. Together, we'll explore the stars, galaxies, and mysteries that fill the universe, right from our own backyard. Before counting stars, let's define one. A star is a massive, glowing ball of hot gas, mostly hydrogen and helium, held together by gravity. At its core, nuclear fusion fuses hydrogen into helium, releasing energy that makes the star shine. Our sun is a typical star, powering life on Earth by converting millions of tons of hydrogen every second. Other stars vary. Some are giants burning fast and bright, others are small and long-lived. Stars are the universe's chemical factories, forging elements like carbon and oxygen. When massive stars die, they explode as supernova, scattering these elements across space. Planets and brown dwarfs aren't stars, they don't sustain fusion. By defining stars, we can focus our search and calibrate our instruments. We're searching for the true powerhouses of the cosmos. When you look up at the night sky, it might seem as if the stars are scattered at random, sprinkled across the darkness without any pattern. But in reality, stars gather together in immense structures called galaxies, vast cosmic cities, each one bound together by the invisible force of gravity. Galaxies come in a dazzling variety of shapes and sizes. Some are elegant spirals with graceful arms, others are smooth, rounded ellipticals, and some are irregular, appearing as chaotic clouds of stars and gas. Our own solar system is nestled within the Milky Way, which is a barred spiral galaxy, one of hundreds of billions in the universe. That glowing milky band you see stretching across the sky on a clear night is actually the dense plane of our galaxy, packed with countless stars, swirling clouds of gas and cosmic dust. At the heart of most galaxies, including our own, lies a mysterious and powerful object, a supermassive black hole, millions or even billions of times more massive than our sun. Galaxies are the birthplaces of stars. Within their swirling arms and glowing clouds, new stars ignite, live out their lives, and eventually die, enriching the galaxy with new elements. To estimate the number of stars in the universe, astronomers use a clever two-step approach. First, they estimate the average number of stars in a typical galaxy, and then they count how many galaxies there are. It's a bit like trying to estimate the population of Earth by multiplying the average number of people in a city by the total number of cities around the globe. Of course, galaxies themselves are incredibly diverse. Some are giants, with trillions of stars, while others are much smaller, containing just a few million. Scientists take this variation into account, using powerful telescopes and sophisticated models to refine their estimates. But the basic principle remains simple. Count the galaxies, multiply by the average number of stars per galaxy, and you get a sense of the universe's true scale. This method transforms what seems like an impossible task, counting every star in the cosmos, into a manageable, awe-inspiring calculation, revealing just how vast and full of wonders our universe truly is. Let's start with our own Milky Way. Counting its stars is tricky. We're inside it, and dust blocks our view. Astronomers use infrared and radio waves to peer through the dust, sampling small patches and modeling the whole galaxy. Most stars are small, dim red dwarfs, hard to see, but numerous. By combining star counts, mass estimates, and orbital speeds, scientists estimate the Milky Way holds about 200 billion stars. If you counted one star per second, it would take over 6,000 years to reach that number. And that's just one galaxy among countless others. Now, how many galaxies are there? Using telescopes like Hubble and James Webb, astronomers stare at tiny dark patches of sky. The Hubble Deep Field revealed thousands of galaxies in a space the size of a grain of sand at arm's length. Each image shows galaxies at different distances and times, stretching back to the early universe. Newer telescopes see even more, pushing our estimates higher. For years we thought there were 100 to 200 billion galaxies. Now the best estimate is about 2 trillion galaxies in the observable universe. Many are faint dwarf galaxies from the early cosmos. With these two numbers, 200 billion stars per galaxy and 2 trillion galaxies, we're ready for the final calculation. The result is truly staggering. Imagine multiplying 200 billion stars by 2 trillion galaxies. The result is a number so vast, it almost defies comprehension. That's 400 sextillion stars, a 4 followed by 23 zeros. It's a figure so large it's hard to picture what it really means. To help grasp this, let's compare it to something more familiar: grains of sand. Scientists estimate that all the grains of sand on every beach, in every desert, and on the ocean floor add up to about 7.5 sextillion. For every single grain of sand on Earth, there are more than 50 stars scattered across the universe. That's not just beaches, but every grain, everywhere. Next time you pick up a grain at the beach, try to imagine 50 blazing suns for that one tiny speck. It's a comparison that stretches the imagination. The number of stars is simply immense. So immense that it's almost beyond our ability to truly comprehend. And remember, this is just an estimate. Galaxies and stars come in all shapes and sizes. And as our telescopes and technology improve, our numbers change. We're only counting the stars in the observable universe, the part we can actually see. The true total could be far, far greater, hidden beyond the limits of our vision. Some stars may exist outside galaxies, drifting alone in the vastness, and as the universe expands, some galaxies are moving away so quickly, their light will never reach us. So, our calculation is really just a snapshot. A best guess based on what we know right now, not a final answer. Still, it gives us a sense of the universe's vastness and reminds us how much more there is to discover. The cosmos is more immense, more mysterious, and more awe-inspiring than we can truly imagine. Our estimate, 400 sextillion stars, isn't final. Science is a journey, not a set of facts. Each new telescope reveals more galaxies, more stars, and more mysteries. The number will change as we learn, and that's the beauty of discovery. With so many stars, most likely have planets. Trillions, maybe sextillions, of worlds. That leads to the ultimate question. Are we alone? Even if a tiny fraction of planets have life, there could be billions of living worlds. The vastness of stars makes the search for life a scientific quest, not just a dream. So next time you look up, remember, you're seeing a tiny sample of a universe filled with hundreds of sextillions of suns. We are small, but our curiosity lets us glimpse the infinite, and that's the most amazing thing of all.